All right. This homework assignment is, as I said, from the last section. And so I just hadn't given it yet. So make sure you get it written down. You should be able to do everything from those sections at this point. So you should be set to go as far as that goes. But we are starting the last section of this chapter, which we're going to build on the ideas that we talked about yesterday, Monday for you guys. And those are the ways that we describe a distribution. Ways that we describe a distribution. So if it asks, give a description for a set of data or give a description for anything like that, shape, outliers, center, spread are the four things that we want to make sure that we talk about and discuss. So today we're going to talk about that in some more detail so that you're used to it and used to some of the terminology and numbers and measurements that we might use to talk about each of these things. Shape. Keywords to describe shape. One of the ways that we have to talk about it is where the peaks are. And so some words that you might see for some of these distributions is talking about modes. And so we have this word unimodal and bimodal. And a unimodal distribution just has one peak versus a bimodal, which would have two peaks, like that. Okay? And it's called unimodal based on mode. If we remember, mode is our measurement that appears the most. We talked a little bit about that on Monday. So unimodal literally means that it has one mode. And by contrast, bimodal would mean that it would have two modes or two different peaks in it. So if you ever see something saying that a distribution is bimodal, it just means that it has two peaks in it. Most of the distributions we look at are going to be unimodal. So let's talk about some of those. If we've got a single peak, well, let's talk about if we don't have a peak at all first. Uniform. A uniform distribution, if you think about what uniform means, it means not as a noun, like you're wearing a uniform, but as an adjective. It's uniform means that it's the same throughout. Right? Everything. If I say that everyone is uniform, I'm saying that they are the same, and so that's part of the idea of wearing a uniform, is that everyone is dressed looking the same. And so for distribution to be uniform, it needs to look the same throughout. So it's going to start and end at a point, and it's going to be the same kind of area and spread throughout the distribution from start to finish. It doesn't have peaks, it doesn't have valleys, it just stays constant throughout. An example of a uniform distribution is if I have, let's say I've got a random number generator, which we'll look at later on in the year. Let's say I've got a random number generator and I want it to give me a number from 1 to 100. If it is a random number generator, then each number from 1 to 100 should be equally likely to happen. And so its chance of happening and the number of times each number comes up should be about the same amount all the way from 1 to 100. That would be a uniform distribution because it would be the same throughout the distribution. Next is symmetric. Symmetric is anything that has that symmetry. It looks the same to the left of the center as it does to the right of the center. So here's something with a peak that is symmetric. This would also be symmetric. The idea is that I could draw kind of an invisible line down the center of the distribution, and we would look about the same to the left as we do to the right. That's what symmetric means. Not always symmetric. Sometimes the data is packed more on one side than the other. If that happens, then we say the data is skewed in a direction. All right? And this is a little bit tricky. Skewed left let me draw that again. Skewed left is going to look like this. And let me explain that a little bit. Skewed left, you want to think about, usually it would be, usually if it were symmetric, it would look the same on the left as it does on the right. And so think about what is causing the skewness. Think about what is causing it to not be symmetric. Well, if I cut out this part over on the left, then it would be symmetric, but it's not. I have these usually kind of extremely low values happening on the left-hand side that's causing it to be skewed. So these few data points over here are skewing it to the left. So skewed to the right looks the opposite. It would look symmetric, except there's these few data points over here that are causing it to be skewed to the right. So that's skewed left versus skewed right. The little tail at the end here, this tail tells you what direction it's skewed in. So the tail's on the right, it's skewed to the right. If the tail's over on the left, it's skewed to the left. So those are some of our words for shape. The most common are going to be the symmetric and then skewed left or right. And then you'll see some of these other words come up occasionally. But symmetric and skewed left or right are the most common ways to describe the shape. That's shape. Before we talk about center, let's talk about outliers. Remember, outliers, we said, were extremely high or extremely low values. And so if we have world records for the this is 200 meters, and so we have a whole bunch of data points, and the world record is probably going to be an outlier, an extremely low time in comparison to the other times. Or we might have extreme high amounts. You know, if we're recording maybe temperature in the winter and one day it's suddenly 75, that's an outlier, because it's not usually. Outlier would be outside of the typical values we're expecting in our distribution. If those happen, then we want to talk about them and think about how we should address them when we talk about our data. We'll talk more about it later, but that's what an outlier would look like. We can also have maybe a cluster of value or a gap between, here's these values over here, and then there's a couple, maybe not outliers, but there's a kind of group of a couple of data points happening over here that are extremely high or extremely low in comparison to what we usually have. That's outliers. Center. This you should be more familiar with. In fact, we were doing it on Monday and Tuesday when we looked at the dot plot and I asked you to find the median. So let's, in case we don't remember how to find the median, let's quickly review how to do that. How many are comfortable with the median and are confident that they can do it. If I gave you a distribution, ask for the median. Okay. So to find a median, to break it down in steps, the median is the middle number. The number that happens in the center of the data. So if I put a list of the data in order from smallest to biggest, the median would say, find the number exactly in the middle. That's why it's a measure of center. Put the data in order. Let me just show you. It's easier to show you than to talk about these steps. 1, 13, 9, 5, 17, 23, 14. Right? First thing we're going to do is we're going to put these in order. Work ahead of me and see if you can get the same answer that I do if you are confident. By the way, if people are tuning in at 10:30 and realize that we started early, I apologize. I forgot we were on a shortened schedule today. That means tomorrow you guys are going to need to tune in about 10 minutes earlier than you usually would. So at about 10:20. 159. I'm actually going to mark these off so I know when I've done them. 13, 14, 17, 23. Okay, fantastic. That's a 17. So next, we basically want to take the high and low ends and cross them off until we kind of converge into the middle. That's what we're looking to do. So I want to take away these two, take away the next inside, take away the next inside until I hit the center. There's the median. That's the middle number, 13. Sometimes we abbreviate the median as MED. Median is 13. So we kind of build from outside to inside. If we work into the middle and there's two numbers, then we're going to average them together. Add them, divide by 2. And that will be our median. That will be our middle number. Questions on that? Questions on median and finding median? Yes? Yep. We'll talk about that in a minute. But you should understand, the thing that you should know is that anytime we have a formula or a process for finding it, usually there's going to be a way for the calculator to do it for us. And there is in this case. And usually you are also going to need to understand how the process works. And we'll talk about this in just a minute, but even if you have the calculator do the median for you, you still need to understand how the median is found. So you know if a question that they like to ask is, if I change this thing about the data, what would that do to the median? And you should be able to answer that without putting it in the calculator. They might not even tell you what the data is. They might just say, for example, let's say all these numbers were off by 1, and I added 1 to every number. What would the median be now? So instead of 1, 5, 9, 13, now it's 2, 6, 10, 14, 15, 18, 24. So 1 gets added to every number because we were off somehow. What would the median be now? It'd still be 14, not because it changes to this number, but because this middle number is still the middle number because it's still in the same order, and the middle number would be 14. So those are the type, you need to understand how the median works so that you know what doing different things is going to do to the median. But there will be an easier way for us, especially if we have a large group of data like you're talking about. But let's talk about the mean. How many are confident that they could find the mean before I explain how to do it, or the average of a list of numbers? Okay, different group this time. Interesting. This is your other main measurement of center. The mean and the median are our main measurements of center. To take the mean, or the average of the numbers, we add everything up and divide by how many numbers there are. Okay, I'll come back to this in just a second, all this stuff, but I want to show you how that works. Same list of data. I don't need to put it in order this time, because it doesn't matter what order it's in. I just need to add up all the numbers and then divide by how many there are. So I want you to do that real quick. You'll notice the mean and the median are different. They're slightly different. And how they measure center is a little bit different as well. And so we're going to, in just a second, I'm going to talk about what those differences are. But I want to talk about all this mumbo jumbo up here. First off, notation. What do we use to label? I said we use MED to stand for median a lot of the time. What we use to stand for mean is something a little bit different. When we have a list of data like this and we've calculated the mean, then we have X bar. That's what we usually use for mean. So it's X with a little bar over it. Another one that you might see is the Greek letter mu. So it's a U with a little tail at the end. You'll see that used for mean as well. Those are the two different symbols. The Greek letter mu, and then X bar. X with a little bar over it. Okay, and this is here is the more general formula for the mean. Let me break this down a little bit. This is what will be on your formula sheet, is the formula for the mean. If you got the answer, then you know how to find the mean. But I want to break down this notation so that you're a little bit used to how it looks. Because this is how college math textbooks like to be lazy. They don't want to write all these words. They have shorthand. So, X bar, so the mean is, well, this is another Greek letter, which across all of math is used to signify a sum. Have you seen this symbol before? Has Honors Algebra 2 shown that? Okay, good. So the sum, and sometimes it talks from a particular value to another value, if we want to get specific. But the sum of the values. Okay, that's the notation. This is saying here's the values. You put the values in and you add them all up. And then we divide by n. Remember, n, we said, was what we used to stand for sample size. In other words, how many numbers there are in your list. So this says, add up all the values and then divide by how many there are. It's just saying it in a really fancy way. So when you see it on your formula sheet, that's what it is. You won't be asked to interpret all these fancy symbols, but I just don't want you to be have it completely mystify you if you see it on the formula sheet. Add them all up, divide by how many there are. Let's talk about the mean versus the median. Okay? What's the difference between the mean and the median of a set of data? So let's say I have the same set of data here. 1, 5, 9, 13, 14, 17, 23. Okay. The main thing that you need to know is that the median is a resistant measure. The median is a resistant measure. And I want to talk about what that means. I want to give you an example to show you what that means. So we have this listed data. We found that the mean was about 11 point something, and the median was 13. Remember how we found those. I do not want you to calculate, but I want you to tell me what's, write down what's going to happen to the mean, what's going to happen to the median. I realized I made a mistake with this data. Instead of 23, it should have been that. Take a minute, write down on your paper what will happen to the mean, what's going to happen to the median. And see if you can mean what's going to happen. Remember how we got the mean. Add up all the numbers, divide by how many there are. It's going to get a lot bigger. This is going to go way up. Because when I add up all the numbers, instead of adding up 23, all of a sudden I'm adding this huge mess. Way up. How about the median? It's going to stay the same. Why is it going to stay the same? Right? It's just taking the middle number of the 7 numbers. So the first thing we're going to do when we calculate the median is say, I don't want this number, I don't want this number. And then the process is the same as it was before. So what we're going to have is, I've got this measurement that the mean is typically a more accurate measurement. But the median will kind of push away those extremely high or extremely low values. So if we've got an outlier, or if we've got a bunch of really high measurements that might throw off the data, in other words, maybe some skewness, then I might want to use the median instead of the mean. It might give a better idea of what the more, because part of center is what is the typical value in this distribution. And if we're looking at a typical value in this case, what's more typical of what we're going to get, the mean or the median? Well, the median, because where most of the data is around 13. If we calculated the mean, we would get something like really close to this number, basically. And that does not give you an idea of what the typical number of this is going to look like. Okay, how about your calculators? Let's look at how this works. Put this data, not this one, put this data into list 1. I'll show you more things we can. So if you exit out of that, second quit, and then you go to Stat, instead of Edit, you're going to go over to the right to Calc. to calculate, and there's a button here that says one variable stat. Hit it. It's asking me what list I want. Some of your calculators might not pop up this menu, but we just want list 1. Calculate, and it's about to tell us a bunch of things. Some of them we should recognize. This one we should know. This is the what? That's the mean. N equals 7 you should know. That's your sample size. We'll talk about these. Here's the sum of all the numbers. Min, the minimum, the smallest value. You should recognize, if you go down, that was convenient. MED, median, 13, that's what we got. So you asked if there's a quick way to do it. One variable stat. We'll talk more about what the rest of these numbers mean tomorrow. They're going to have to do with measurements of spread, because we haven't talked about that, and it's going to tie into how we're going to tell if something's an outlier or not. So we talked about shape and center today. We're going to talk about spread